Hi, a student has requested assistance with a couple of questions, so let's have a look at those questions in mind. The first one is this pesky little denominators. Um, there's two ways of approaching this one. I think in the solution they just chose that because the denominator is the same, we can easily subtract fractions. But one other option is, of course, is to eliminate that pesky x by multiplying everything by x. So multiply all both sides by x. Okay, so multiply both sides by x. So we multiply every term by x. That, of course, will get rid of those pesky denominators, and we're just left with minus 2 minus 7 equals minus 5, and of course we multiply the other side by x. Now we can subtract the 2 minus 7, which is minus 5, negative 5x, and then divide both sides by negative 5, because remember we're trying to get the x by itself. We get x equals 1. And the best thing about all these things, you can try your solution. So it's a case of making sure that the left-hand side equals the right-hand side. So on the left-hand side, we had 2 over x minus 7 over x. And on the right-hand side, we had minus 5. So let's have a look. Substituting our answer, we have 2 over 1 minus 7 over 1. Does that equal to minus 5? 2 minus 7 equals minus 5. And as you can see, we have the right-hand side equaling the left-hand side. So that's the correct solution. All right, the next question is to do with linear equation. Of course, remember linear equations can be in three different forms. Y equals mx plus c, ax plus by equals c. And this one is just brought the c term to the one side. Don't let that bother you too much. So all we're going to do is we're going to make sure that when we finish the equation, it's in that form. So let's have a look at the first one. We have been given the 2 points. So that's a classic work out the gradient first using the y2 minus y1 over x2 minus x1. And here you need to make sure that you keep track of your terms. So we have y2 is 2, always take away. Y1 is negative 2, so don't forget that directed sign. And x2 is 5, take away, again take away negative 3. And we end up with 4 over 8, or m equals a half. We can now substitute into that great equation, which Mr. Devon thought was fantastic. So let's do that. That's because we've already got the gradient. Now we just choose one of those points to substitute. We might as well choose the second point because it's dealing with nice numbers. So we've got the half brackets x minus and y2 was. There you go. That's why you need to track. So you got the 5 as the y minus 5 and the x. The y was that should have been 2. All right. And then we just simply expand the brackets, which is a half x minus 2.5 plus the 2 is minus a half. I think that's right. Let's double check because I skipped the line. Half minus 2.5 plus, yep, that's correct. And now all we did is bring everything to one side. So the terms, those two, we're still just bring the y across. So it's a half x minus 0.5 minus y equals 0. And remember, those pesky fractions, so we just multiply everything by 2 this time. In other words, we'll get rid of them. So multiply that by 2, we get x. Multiply that by 2, we get 1. And multiply that by 2, we get minus 2y equals 0. And yes, we might want to swap those two terms around. So that's the solution for that one. And finally, this one here is we must read carefully. So again, we just place that or rewrite that in the y equals mx plus c format so that we can work out the gradient and then work out the perpendicular gradient. So we have 3x plus 6y plus 1 equals 0. We'll take the 6y across. So that's 6y, which is negative, because we subtract 6y from both sides, and leaves us with the 3x plus 1. Divide everything by negative 6. And we have y equals negative a half x minus 1/6. The important thing we want from this equation is the gradient. The gradient of the line is negative a half. And then, so we'll call that equation 1. And the perpendicular line is the negative reciprocal. The opposite of minus is a plus, and the reciprocal is 2 over 1, or positive 2. And now we know one of the points on this particular perpendicular line. Again, we get that fantastic equation that Mr. Devon likes. That's this one here. Let's see if I don't stuff it up this time. That's y minus y1 is minus 1. The gradient we just worked out is 2. 1 is the x value. I won't do it all in one step, so I'll do the expansion and the simplifying. It's 2x minus 2. Subtract 1 from both sides. Y equals 2x minus 3. And now we bring everything to one side, and then I'll subtract y from both sides. So I have 2x minus y minus 3 equals 0. And there's your solution. I hope you find that useful leading up to the test this week. Have a good day.